In this question, you're asked to show that d by dx of x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a is equal to root of a square minus x square. So let us differentiate this step by step. So x by 2 into root of a square minus x square. It's a product of two functions. So the differentiation is 1 by 2 is a constant. We can take it out. So u v dash plus vu dash. X times the differentiation of this is 1 by 2 root a square minus x square times the differentiation of a square minus x square is minus 2x. So u v dash plus v a square minus x square times the differentiation of x is 1 plus a square by 2 is a constant. So what is the differentiation of sine inverse of something? 1 by root of 1 minus something square times the differentiation of this something. What is the differentiation of x by a? It is 1 by a. A and this gets cancelled. That is equal to this 2 and this 2 also gets cancelled. So 1 by 2 times minus x square by root of a square minus x square plus root of a square minus x square plus. So if you simplify this, if you take the LCM, you get a square minus x square by a. This a goes up. So you have a square by 2 into 1 by root of a square minus x square. So now let us take 2 root a square minus x square as the LCM. So what happens if you take 2 root a square minus x square as the LCM? So you have a minus x square here. So this 2 is there for this also. So you have a root of a square minus x square into root of a square minus x square is a square minus x square and have plus a square. That is equal to 2a square minus 2x square. This 2 times a square minus x square by 2 times root of a square minus x square. This 2 and this 2 gets cancelled. So a square minus x square by root of a square minus x square is root of a square minus x square. So this is what you're asked to prove. So hence proved.